Okay, this section, guys, is going to be on chord lengths. Okay, chord lengths. So, or segment lengths. And there are several different types of ones you can come across with. Okay, the first one is when you have two chords that intersect in a circle. Let's say like these two. You have part A, part B, part C, and part D. And what the theorem states is that A times B equals C times D. Okay, so if I do another one here and change colors, let's do it in red. If these two arcs cross, let's say like this, and this is 2 and this is 12, and this part's 3 and this part is X, you would say 3 times X equals 2 times 12, 3X equals 24, and X equals 8. So that's the first type. That's when you have two chords crossing. That each part, that's not half and half per se, but one part times the other part equals the other one times its other part. Okay? Now the next one comes up is when you have two secants. But through a circle. Let me show you the picture. So let's say we have this one and we have this one. We'll call this part A, we'll call this B, we'll call this C, and we'll call this D. Now in words, what you need to remember is this. The total times the outside equals the total times the outside. Squeeze it in there. All right. In other words, it means this. A plus B, which is the total of the top one here, times A, that's the total, times the outside, would equal the total of the other one, C plus D, times its outside of C. So the total times the outside equals the total times the outside. Now let me show you one with some numbers in it. Let's go with blue this time maybe. So let's say we have, well, let's put it over this way this time. Let's say this is X and this is 6. And over here we have 4. And that this part here is 10. So I would say the total, 14 of the one, times the outside of 4, equals the total of the other one, times the outside of 6. Well, 14 times 4 would be 56. This would be 6x plus 36. Subtract 36 gives us 20. So x equals 20 over 6, i.e. 10 over 3, which you can leave it that way, or you can call it 3 and 1/3. So they don't always come out pretty, but just remember that the outside times the total, okay, the outside part times the total, or the total times the outside, whichever way you want to go. So the total here is 14, 10 plus the 4, okay, it's 14. 10 plus the 4 is 14, times just the outside part of 4 is equal to the other one of the total x plus 6 plus its outside just 6, and then you do the math, okay? All right, the next one is when, this is the hardest one, is when you have a tangent and a secant line. Let's go, I'm thinking green this time maybe. So here, is a tangent line, and here is a secant line. That gives you three parts. We get part X up here, part A here, and part B down there. Now the formula for this one is the outside, this little tangent piece up here, that squared is equal for the other one as the total times the outside part. So in other words, x squared is equal to a plus b times just a. So let's put some real numbers in here in this case. Okay, we'll put some real numbers inside to make it a little bit different. Let's say, just an orange, that this little piece is x still. We'll call this 6 out here, and we'll call this, 12 on the inside. So we'd say x squared on the outside is equal to the total, 18, times the outside part of 6. Okay, so x squared is equal to 6 times 18. Okay, so 6 times 18, my calculator's going to be a decimal involved in this one. 18 times 6 gives you the 108. So x in this case, push it up a little here. X in this case would equal the square root of 108. And the square root of 108 you can put as a decimal if you like. 10.4 roughly, approximately 10.4. Or you could also break that down. A little practice here. 4 times 25 is 100. Add 2 more, 4 and 27. Would give you 108, which could be 4, 9, and 3. Which is 2, 3, root 3, or 6 root 3. So I would take 6 root 3 or use the decimal 10.4. The key part is to remember that the outside x squared, okay, is equal to the total part, a plus b, times the outside part, just a. Okay? So that's how you work with the terms of the totals. All right, so we have, to review, we had two situations. We have a chord and a chord. Right here with two chords crossed, that's the easiest one. A times B is equal to C times D. It's pretty simple. Then you have the two secants. The total length, A plus B, times the outside part A, equals the other total times its outside, C plus D, times the outside C. Now, they'll give you different parts in the problems. Sometimes you're solving for one part or another. Sometimes you get a quadratic, but as long as you set it up with the words and plug the numbers in, the rest is just algebra. And then we have the tangent and the secant, where the tangent on the outside squared, x squared, is equal to the total times the outside part there as well. Okay? So there are various types of problems in here on the lengths of segments. And there's going to be some problems in Delta Math for this to do, and also some problems out of the textbook, which I'll assign here in just a few minutes. Come back and refer to this as need be.